Problem 4. It says ABCD is a rectangle. So we have a rectangle here. AC's length, that length is 50. Well, if that's 50, I know that's 52. Special thing about a rectangle, diagonals will always be the exact same length. Just like a parallelogram, because they're a type of parallelogram, these guys will bisect one another. So I know if that's 50, I do know that I have, this is 25, 25, 25, 25. I'm not sure that's what we're going to use here though. It says BC is 40. So I know B to C, here's C, B to C, this leg is 40. If that's 40, I know the bottom leg is 40. Now I'm trying to find the length of this leg here. Well, I do know that in this case, A to C is 50, which means that's 50. Well, we'll just label this right here as 50. Now notice if we do this, the other thing with a rectangle, all the corners are 90 degrees. This is 90 degrees right up in here. If I forget this little line right here for the time being, notice you have again a right triangle where you're given the hypotenuse of 50, a leg of 40, and you're trying to find this missing leg. This missing side's leg length will be the same here. Or if you wanted, you can imagine this rectangle right here to get it right off. You got 40, you got 50, you're trying to find this missing side, we'll label him A. So I know A squared plus this leg 40 squared equals the hypotenuse, which in this case is 50 squared. Now, I know that's going to be 30. I can see it right off because of 3, 4, 5 triangle. But if you wanted to go through and do the math, you would see A squared plus 1600 is equal to 2500. Subtract your 1600 from both sides, you're going to get 900. And then take the square root, you're going to get A is exactly a 30. That length, C to D, what it's asking for, is exactly 30 centimeters. Again, rectangle, special thing. Right angles in the corners, but the other big thing to always look for, especially on the SOL, is the diagonals will be exactly the same length. But in this problem, what we were looking for was that length on the side, and it was 30 for us.